Good morning, students. Today I am going to explain the analog and digital communication lab. In that, the sixth experiment is delta modulation and demodulation. So this is the trainer kit which consists both modulation and demodulation. So to observe the waveforms, I am going to use digital CRO. So in the delta modulation and demodulation, we are having the transmitter and receiver. So to observe the output signal, I am using the bistable circuit, so which takes the data input and clock input as a signals. So to get the clock input, I am using a pulse signal that is called transmission clock signal, which gives the number of frequencies, that is 50 kilohertz, 100 kilohertz and 200 kilohertz and 400 kilohertz. So like this we can provide the different frequencies to a clock signal. So to get the 50 kilohertz frequency, I am using these two knobs at 0 0 logic. So the 0 0 logic will provide the 50 kilohertz clock signal at a transmission clock signal. So to observe this waveform, I am going to connect positive knob of the CRO to the transmission clock output, and negative knob is connected to the ground connection. So this will give the clock signal with frequency 50 kilohertz. So if we want to change, we can change the toggle switches of the logic. It will provide different frequencies for the clock generator. So this is the clock generator available on the screen with 50 kilohertz frequency. Now we are giving this 50 kilohertz frequency to the clock input of the bistable circuit with a patch cord. So I am giving this clock signal to the clock input of the bistable circuit, and I am using a message signal from the signal generator with different frequencies. So 1 kilohertz, 2 kilohertz, 3 kilohertz, 4 kilohertz, like this different frequencies are available from the signal generator with single fixed amplitude 10 volt peak to peak. So I am connecting a 4 kilohertz message signal on the signal generator. So I am observing the signal waveform from the CRO. So this consists 4 kilohertz frequency with 10 volt peak to peak amplitude. So now I am connecting this message signal. I am connecting this message signal to the circuit diagram which is available in the transmitter. So in the transmitter, I am connecting the message signal to the comparator's positive terminal input, that means non-inverting input terminal. So 4 kilohertz sine wave is given to the comparator's positive circuit input. So why I am connecting this means, in the digital modulation, the output of the circuit is given to the input again to compare this data to get back the only zeros and ones of the digital data. That means each and every sample is allocated with only single bit. So for that purpose we are getting the digital data output as a unipolar. So to get the same signal as a one more input to the comparator, the unipolar data should convert into bipolar, and the bipolar data is given to the integrator. That integrator output is given to the inverting terminal of the comparator. So first I am connecting the output of the unipolar to the bipolar. Simply bipolar signal is connected to the integrator, this one, and I am connecting the output of this integrator to the comparator to get a proper digital data output with single bit per sample. So this is the transmitter circuit. Now I am going to observing the data, final data output in digital format. So here the comparator output is connected to the one more input of this bistable circuit. Simply I am using the data flip-flop. We are calling that as a D flip-flop. So this is the digital data available at output of the delta modulation. So for each sample we are having only single data bit. So same signal is given to the receiver to get back the original message signal. So here I am using the same signal which is transmitted at data output is given to the data input of the same bistable circuit available in the receiver. So for this bistable circuit also we need clock signal. That clock is available from the receiver clock output, but this clock output should consist frequency is equals to the transmitted clock frequency. So already in the transmitted clock frequency we are using 50 kHz frequency. So same 50 kHz frequency is available in the receiver clock also, that is given to the clock input of the bistable circuit, and the data input is taken from the transmitter output. So this is receiver input is connected to the transmitter output. Then this will given to the data in unipolar. So this unipolar again converted into bipolar form. So that bipolar is given to the integrator, and this integrator will provide the output to the low pass filter. This will generate the final message signal or simply demodulated signal. So I am connecting bipolar output to the integrator, and the integrator output is connected to the low pass filter. And to observe the output of the low pass filter I am connecting here. So this will provide the recovered message signal from the demodulated. So this is the demodulated output available in the delta demodulation circuit. So this is the delta modulation and demodulation experiment. Thank you.